we're going to go through problems and just start going through these problems from our review packet. But you should also go over your old tests and your old packets, okay, your old chapter blocks in preparation for the exam. Our exam is on Tuesday morning, 9 to 11 in here, okay? Bring your calculator, bring your review sheet where you could write equations on your review sheet, remember? Reference table, yes, sorry. Bring your not your review sheet, your reference table. No. Reference table with questions, you can bring those. And so you have to be here at least an hour and a half. You have up to 2 hours and 15 minutes. Okay? So we'll review today and tomorrow, and an E-block I'll review tomorrow as well, and I'll paste all the notes and videos from both so on there. So let's just start with this first problem here. Well, we did these. It's not, once you get it, it shouldn't be all that hard. Where'd it go? Well, that didn't work. There it is. All right, so given the equation S equals 8t plus 5, where S represents squid and T tangerines, determine the units on 8 and on the number 5. Now, so on this side of the equation, you have to have squid as your units. So everything that you solve for over here must also give you squid. Okay? So how do we get squid from this? Well, when we plug in T, we'll be plugging in what? Tangerines, right? So that means that the units on 8 must be what? Tangerines has to be on the bottom and squid on the top, and that will leave you with just squid. Now, this one over here, we're not plugging in anything into it. So that the units on the 5 must just be squid. So this will give you squid, because the tangerines will cancel. And then this will give you squid, and we need squid on both sides. That's just the units on the 8. So if you plugged in 5 tangerines, you'd have 5 times 8, 40 squids over there, because the tangerines would cancel. No, it's what are the units on the 8? So it's like this. It's like you have an axis where S over here in squid and T on the X in tangerine, and like Y equals MX plus B. So 8 is your M, and of course the slope is, how do you calculate a slope? Change in what over what? Y over X, squid over tangerine, right? MX plus B, what is B? Y-intercept, 5 squid, right? So a more real world example would be position S, because remember S is position, delta S on our chart and everything, and that's meters versus time T, and that's seconds, and we could have something like that, and we would have the equation, our position equals 2 meters per second times T plus 1.2 meters. So here, instead of squids over tangerine, the units on the slope are what? Meters over seconds, which makes sense because it's going to cancel the seconds that you put in here and leave you with meters, right? And then this is meters over here. And we did that one where we had to find the number of dollars, remember? So one could be, if you put in quarters, you would have to, if your units on both sides have to be dollars, we would have 0.25 Q over D's, or D's over Q. So how many dollars do you have? We had that one. Well, the number of dollars you have will be equal to 0.25 D over Q are the units times quarters, the number of quarters you put in, plus 0.10 dollars over DI for dimes times the number of dimes you put in, plus 0.05 dollars over nickels times the number of nickels you put in. I was going to spell it like our name. Plus 0.01 times the number of pennies. Oops, I mean dollars over pennies. Like that, right? Each of these units on here, quarters cancel to give you dollars. The number of quarters you'd put in, and then those quarters, the units would cancel, give you dollars. Here the dimes would cancel, nickels and pennies, and we'd have the number of dollars. Okay? I don't know if you guys understand that or not. Some of you? You did 20 minutes ago? You don't understand it? Well, tell me why did I put D over Q here? Well, because what do I want to get over here? Dollars. So what does each of these terms have to be? The dollars. And if I put in 5 quarters, quarters has to cancel, and the conversion factor is $0.25 per quarter. Yeah. The same thing's going on with the slope, y over x. And when we put in that x value, we're left with the y unit for the other side. All right. How about, oops. List 3 fundamental measured quantities and their associated standard units. That's just sort of remembering what they are. Anybody remember one? Michael? You have an amazing way to transfer your voice. You can do the next one. What's the first? Distance. I think that's what. So the fundamental quantity is distance. The associated unit is meters, right? What's another one, Vera? Seconds is the units. Sorry. And time. One more, Carolyn. Mass. Now we did some derived units from these. Speed or velocity. Meters per second, right? Distance or length over time. Acceleration, meters per second, a distance over a time over another time, a rate of a rate. Force, kilograms times meter per second squared, a mass times the length over 2 times. Okay? Crust, sorry. I posted a review from last year for your viewing pleasure over the snow days. Who watched it? 4 of you. The rest of you, shame on you. On Schoology, I posted that. I posted a whole bunch of solutions. I posted an update that said I did. Well, if you go there, you could see, well, I'm not going to go there now, but you can see it. 8 decades into seconds. My plan is going to be to go to decades, to years. It's up to you. Days, hours, minutes, seconds. So, 8 decades. What goes on the bottom? What goes on top? Decades on the bottom. Because what has to happen, Aiden? It has to cancel, right? So what is it? Now I know I could just fill it in. 10 over 1, right? I put 1 up there, sorry. 10 over 1. That gives us years. Year on the bottom. Days on the top. If I want to be closer to accurate, what would I put for the number of days per year? 365.25, right? Goodbye years. Days on the bottom. 24 hours in a day. Hours on the bottom, minutes. 60 minutes in an hour. And 60 seconds per hour. So everything's on the top for this one. That helps you. You could do that. Put it over 1. So it's just 8 times 10 times 365 times 24 times 60 times 60. Eight times 10 times 365.25 times 24 times 60 equals a lot of seconds. 3, 6, 9. 2.524608 times 10 to the 9 seconds. Not necessarily. Okay. I keep doing the wrong one. I'm sorry. Well, I'm not too sorry. It happens. What is the magnitude of vector P? This is the toughest one on there, I think. No offense, Carolyn. What is the magnitude of vector P? All you have to do is remember what magnitude is, right? It's just 60 meters. That's it. It reminds me of my differential equations test that I took in college, one of them. And there was the first question on there. All you have to do is take a simple derivative, which you'll learn later, but it wasn't all that hard. It's not hard to do. But then there's these complicated differential equations that we were learning, and I forgot how to take. I didn't forget. I just didn't put it together. Like all you have to do is take the simple derivatives. I'm like, what is it? Which complicated formula to solve this? I don't remember. All I had to do was do the little thing on it. So he was my math teacher in college, and my math professor, and then he ended up marrying my sister after. So I came back out there when I was in grad school, and my sister's like, "Oh, I'm getting married, and who you're marrying?" And she's like, "This guy," and I was like, "Oh, that's my old math teacher." It's true. He's a little dry, so he still is. He knows it. Of course, some of you would probably say the same about me, or other things. Some version of it. What is the displacement of a runner who runs 4 laps? Okay, so distance would be what? If he keeps going around, cheated. So the distance traveled would be a mile, because 4 times around, right? But the distance is 0 because displacement is what? How far from start you are to where you ended. So in another example, so this would be 0 miles. If we put a little chip in Michael's head and we could control him, right, with Mr. Hiller's Nintendo movement things for his robots, and we had Michael walk like that, and then Michael walk like that, and then Michael walk like that, and then like that, and then like that, we could add up all these segments for his distance, which in symbol form is like that, change in position. But the change in position with relation to where you started is a displacement start to finish, right? Yeah. This is a vector quantity. Yes. be equal if you walk in a straight line without moving back. No. That's the next generation of robots. Right now, well, okay. Moving on. Okay, so if a given vector A is defined as A equals 20 meters at 90 degrees, write out the value of the quantity minus 3A. So 20 meters at 90 degrees might look like that if we do it on a typical XY way, right? Like that. Where this is 90 degrees right here. Minus 3A is going to take 3 of these and reverse them all. And then have them go down. So minus 3A will look like that thing. Okay? What's the length of it? 60 meters. There's different ways to put this. We could put 60 meters at, someone said 1, what was it? At 270 degrees, because that's coming around like this. We could do what else? Well, close. We could do negative 60 meters at 90 degrees, and then the one that Michael was getting at was 60 meters at minus 90 degrees. But we're not using north-south in this problem, but minus 90 would say down. So there's really, but you don't want minus 60 at minus 60 at minus 90, because that would be this, going up that way. All right. Find the length of the missing side of the right triangle. Well, some of you have done this for multiple years. Some just learned this year. But you all know how to do a squared plus b squared equals c squared, right? So that would be 60 meters squared plus 60.82 meters squared, right? No, that's not right. So that happens. Don't make that mistake. 60.82 meters squared, right? So b squared equals 60.82 meters squared minus 60 meters squared. B equals the square root of oops. Well, it shouldn't be. It should be pretty small. Obviously not drawn to scale. 9.95. Find an x and y components. Uh-oh. Nope, I got it. Well, we want this thing. We'll call it like AX and AY. And that's the 30 degrees. And that's hopefully real simple for you now. Or maybe you need to remember it. I don't know. AX is 20 meters cosine of 30 degrees. And AY is 20 meters sine of 30 degrees. Point what? 3 meters and 10 meters. So that's pretty simple. Moving right along. So Jenny walks 30 meters west, 40 meters north. Mathematically, we're going to find it. In terms of graphical ways, you do it with a scale, right? 1 centimeter equals 2 meters, something like that, right? And then you put the vectors and you use a protractor and you do it that way. But this says mathematical, so we'll do it where Jenny walks 30 meters to the west and then 40 meters north, like that. That's right, because her displacement will be a vector like this. That's displacement there. Now, oh yeah, it is. That's nice. That means that delta S, we don't even have to plug it in. We know it's going to be 50 meters, right? 3, 4, 5. How do we get direction for this thing? Right, so if I find this theta here, okay, and Caroline was saying, take the tan inverse of what over what? Well, if I do the negative, it's going to give me the value down in the calculator doesn't know what's negative, if the x is negative or the y is negative. So if you do it, it will tell you minus 53 degrees. But minus 53 degrees would mean like down here. It gives you the thing. So we'll do 40 over 30. And when I do that, I think it comes out 53, right? That's 53 degrees. So if I wanted this angle, I would know it's what? 180 minus 53, or 127 degrees. So if I wanted it in that x-axis orientation, although a sketch on there and you find 53 degrees would be okay for me, but you never know. You need to do it some other time. You could write it as 50 meters at 127 degrees. Yeah. Is the vector opposite to delta S, the displacement? That's the equilibrium. That would be 50 meters at minus 53 degrees, or 50 meters at 300, no, 270. What? 360 minus 53, what is that? 307, yes. I was trying to add 360 to 127. That's 180 plus 127 will give you 307. That makes sense. Okay. Yes. What about more specific? Use angles. Well, it depends. I mean, a key really tells you on the map. So if you have x-axis drawn and then like a little theta with an arrow around, then if you wrote on there 50 or 100 meters at 100, well, by standard that we've been doing, it's from the x-axis. But the other way to do it might say you figured out 10 degrees and it was off like that, then you could say 10 degrees, and you were using north, east, west, south. You could say 10 degrees north of east. Then you could say, well, if it was down like here, you might say 80 degrees south of east, or 10 degrees east of south. Yeah. I'm reading this book now on maps. Anyways, I'm not going to go into that, sorry. Standard notation, 25 miles. Okay, it's exam time, right? And I don't remember how many meters are in a mile. What do I do? Oh, the reference table. I brought it with me. That's good. So, is it on there, meters to miles? In 1 hour, there's 60 minutes. In 1 minute, there's 60 seconds. Yeah, yeah. Yeah. So this becomes, on top, I have 25 times 1609. On the bottom, 60 times 60. And my units end up giving me meters per second. So that gives us 11.2 meters per second. Next question. That's possible. course, the hard part for me right now will be the scale. I actually don't have the piece of paper. I just have a picture of the piece of paper up on the big board, right? So when I get out my ruler, where's the protractor? There it is. Get out of here. Ooh. Okay, so the first thing says 6 miles west, starting here, which would be that way, and I have 1.8 millimeters, or 18 millimeters, which is 1.8 centimeters, is 2 miles. So 6 miles west will give us how many? Two miles, 18 millimeters, that equals 54 millimeters. Now, if I was to do that on my scale, that would put me out over here. So, but that's not right. Where does it actually put me? Anyone do it? Did anyone do it? Let me see it. It goes right to the little junction, close to the junction. So I'll just shrink this down. Well, I know that doesn't make any sense, but right there. Okay, so I'm pretty close. It goes to about there, right? Okay, now I got my ruler set to the right scale. 8 miles at 45 degrees. Okay, first thing I'll do, whoa, crap, rust. Oh, I'm trying not to swear. Swear. All right, so now 45 or 8 miles would be 72 millimeters or 7.2 centimeters. Am I close? A little off. 4 miles south would be what? 4 miles south is 36 millimeters, right? Or 3.6. So, yeah, oh, you end up right over here. So, the displacement then will be a vector like that. And if I measure the length of that vector, oops, if I measure the length of the vector, I get about 1.4 or 14 millimeters. 14 millimeters. And 14 millimeters from my scale (1.56 miles). Yeah, especially since I'm doing it on the board. Okay. Now the angle that it's at, if I take my protractor, put it on there, I get about 100 degrees over like this. So it would be 1.56 miles at 10 degrees Maya west of north. See, I could do it that way. Or you could write 100 degrees and put the little scale on it from the x-axis. Or you could do 80 degrees. Yeah, it was, well, that's all right. Was it before? Was yours like that, though? It was more over here? All right. Yeah, then that would be all right. Yeah, with a sketch, I'll know what it means. Well, we're going to come back to this tomorrow. The bell's going to ring. So